added. And so you can kind of get a feel for what I'm doing by looking at the git commit and the commit history per each commit. So you're not going to come out of this session today being a, I don't know, JavaScript master, but you will know enough to be dangerous, and you will know enough to be able to learn more. And I think that's more important than just copying down code, is that you should know how things work to a level that helps you learn more and get more friendly and more comfortable and not scared of the technologies that we'll be going through today. So the first technology we'll be looking at today is JavaScript. It's a powerful client-side programming language. It's not related to Java, although it does share its C-like syntax. So yes, if someone in an interview asks you, do you know Java? And you're like, yeah, I know JavaScript. Or if they ask you if you know JavaScript, then, yeah, I know Java. Totally unrelated. It makes you look silly. Don't do that. It initially was used for dynamic client-side scripts. It was the first and only at that point in time client-side language, which meant that it didn't run until it was on the client side of the world, so generally within a web browser. And now, thanks to Node.js, it actually runs server side as well, and React Native runs locally in some operating systems. In modern web development, we don't use plain vanilla JavaScript. JavaScript is quite powerful. It's quite, because of its power, it lets you do things in many ways, in a multitude of ways. And so to kind of keep things more, what's the word I'm looking for? We'll keep things more granular, keep things more the same and easier for other people to read and look and work on. We use frameworks. There's many frameworks out there like Vue, React, etc. Today we'll be using React. So we'll be looking at React, and it's technically a library. So you'll see a link at the bottom of this slide, shows you about JavaScript basics. If you click it, it will take you there. If you click on this, it will take you to React. If you click on this, it will take you to the definitions of a framework. The second technology we'll be looking at today is Node.js. You can read the definition if you like, but in essence, what Node.js lets us do is it lets us run JavaScript as server-side code. So as mentioned previously, JavaScript is mainly client-side, or rather used to be only client-side. However, using Node, it lets us run it server-side, which means that we can create a backend in JavaScript as well as a front-end. We won't be doing that today, but it's something to know. It's a useful technology that we will be using bits of it. The second to last technology we'll be using today is called Yarn. As mentioned, JavaScript quite widespread, Node also quite widespread. And so if you're thinking of writing some code, probably somebody has already written it. And well, as in other languages, it works with the concept of a library. And these libraries are generally considered as packaged into packages, and using a package manager has advantages when it allows us to interact with these libraries. And there's two primary package managers used with Node.js, or nowadays JavaScript. The first is NPM, which is Node Package Manager. The second is Yarn. Today we'll be looking at Yarn. Yarn has some advantages over NPM. I guess for me, the primary advantage of Yarn is that it does things in a multi-threaded way. So with NPM, if you have to install 100 packages, it will install the package one at a time. With Yarn, it installs them simultaneously, amongst other things. But we'll get into it a bit more later. Finally, the last bit of technology or library or framework, technically it's a library, but some people call it a framework, is React.js. It's a JavaScript library that's used for building user interfaces. It was created by Facebook to help just make building user interfaces much quicker, easier, and more consistent. And it uses a syntax called JSX. It's an HTML-like syntax. And it works in this the theory of a one-page application. And on this one-page application, it loads up pieces of code, which are called components, with a parent component usually called the app.jsx. So that's a brief introduction to the technologies that we'll be using today. At this point, are there any questions from the four of us?
Oh, for me, I think it's fine for now.
Okay, cool. Okay, so just a brief recap of
no questions.
Okay, cool, covered. A brief recap of where we are in this web dev series or seminar. In session one, we learned about the various technologies. and various theories on web development and what's required for web development. We learned about things like JSON, we learned about things like REST, and other concepts that we would be using later on. In the last session run by Z, we learned about backend programming using the Django REST framework with the Python language. And today we will be primarily focusing on the front end component of web development. So we won't actually be going too in depth on like hosting a website or those various options like hosting databases online. We will be primarily focusing on just the front end portion of the application. In this case, it's our blog application that we've been building on over the past couple of weeks. So when running a web application, there are, however, various architectures that one needs to consider when designing a web application. So this is probably the only hosting portion that we will be looking at today. And it's architectures that which can be used to run a certain backend and a certain front end. And in this case, we'll be using a Django backend with the JavaScript front end, and each of them have their own pros and cons. So there's primarily four which I used. This number one is generally called a single page app with distinct hosting. So you have your browser speaks to the front end, which runs in its own service on its own server somewhere, and your browser also speaks to the back end, generally via the front end. Also, which can live on its own distinct service and server. The advantage of this is that these two are completely distinct. And if you're a complete front-end programmer, generally this is the architecture you will work in, because you only have to really worry about this component. All you need from this component, from the backend component, is kind of an exposition of the APIs it exposes to you. So this backend can be something you built, it can be something someone else in your team can be built, or it can be something public that already exists. So your front end just needs to know the backend APIs that are exposed, the payloads that are required, and any other arguments that are required. The other one that's used quite commonly is the second one over here, where the browser speaks to the backend. The backend hosts the backend APIs, but it also hosts the static front-end files. So your browser talks only to the backend. The backend loads up the front-end files when required, and then when you need to access your APIs, for example, you still only talk to your backend. This is another common design used for smaller apps. However, this couples your front end with your backend because your front end is inherently loaded by the backend. Number three is almost inverted of that, is where your backend is loaded by the front end. And number four is very similar to number one, except you have a reverse proxy, something like an Nginx in front of it, where this handles which calls to make to which service. So instead of your browser making the call to the front end when it needs to get a front end component and to the back end when it needs to make a back end call, your browser just speaks to the proxy, and the proxy knows where to call and where to get the data from, and that's passed to your browser. So today we will be using architecture design number one, which is a single page app. As I mentioned, this loads up the JavaScript app on its own server, and your backend is hosted on its own server. And for today, and the primary reason why I think the design, can be argued, the design fits for today is that it's flexible. So in this case, I don't know what Z created. Let's presume I didn't know what she created. She just gave me a document that said, hey, if you call this backend, these are the APIs, these are the URLs that you can hit, these are the payloads to expect, and these are the arguments that you can that you must provide. So I'm not touching the backend today. I don't have access to the backend in inverted commas. I only have access to the front end. So I will load up the backend in its own service. I will then load up the front end on its own service, and the front end will then your browser will then be making calls to both of them respectively. So let's get started. So as mentioned, we will be using the React framework. You can bootstrap this yourself. It gets a bit complex if you want to do that. Facebook has created a nice NPX app that does this for you. It's called Create React App. This basically creates a dummy JavaScript application for you with React installed, with all the packages already installed. it's quite magic, and it's probably the default way that people do things nowadays, because it just simplifies the process almost indefinitely. Like it gets you set up in a matter of 5 minutes. So if you were starting from a vanilla application, you would run, in this case, because we're using yarn create React app. That tells it to create a React app, and you give it a name. And in this case, we'll be using my blog. And so if you're following along from a vanilla state, you can run this command, docker compose run frontend yarn create React app my blog, and it will do so. Alternatively, you could check out this git commit hash, and it will show you the state of the files at that point in time when you run this. So we can do that quickly. So if we just check out that commit, and if we go to front end, we'd see that it creates a very basic set of files, a very basic app.js, which creates a dummy React app for us. It loads up some favicons, it loads up all the packages which we need to run a React application, and it sets up with the basic React scripts. Cool. So then the next thing we then need to do is, well, add some or learn rather, is how to use some packages. So we mentioned that we have this concept of packages, which is almost the Node or JavaScript word for libraries. And so when we want to add this code to our project, we need to add a package. And because we're using yarn as our package manager, the command is simply yarn add. Okay, so you can run this again natively locally, or you can run it via Docker Compose. As an example, later on, we will be using the React router DOM package. So you can install it at this point running this command. If you're using the branch, it's already installed, but you can run it just to learn how to add packages. So what that would do is, if you look at your dependencies in your package.json, you'd see that it will create a line under your dependencies with the name of the application and a version using the semver package. So this would be at minimum version 6.2.1, and it can upgrade up to version like 6.2x. Yeah, so and it will also download the module locally in this node modules folder, and that would be the libraries that you just installed. So any other libraries that you require, you'd run yarn add package name, it will install it, it will add it to your list of packages, and it will install it to your node modules folder. The second important aspect of the React application is your app.jsx. If you recall earlier, I mentioned that React applications are single page web applications. What that means is it loads, when your browser accesses this web page, it serves a single bundle. And this bundle generally loads up from your app.jsx. It acts as your parent component. So once again, if we look at git hash of this at this point in time.
And sorry to cut you, Tamis.
Sure.
So I don't know, maybe you are trying to show us your terminal with.
Oh, can you not see my terminal?
Yeah, because we only see the slide.
Oh crap. Okay, let's try this again. Okay, can you see my terminal?
Yeah, we can see it now.
Okay. Well, they didn't really miss much. Okay, so what I was referring to earlier is the package.json. This is the place, if you add, for example, React router.dom, when you run yarn add package, this is where it will be added to, and it will be added to your node modules. Cool, so that's basically caught up. So to go back to app.jsx. So remember that I've said that your application is a single page application. So when you access your web page, it loads a single component, and in this case, that's your parent component called the app. Called the app component, which we load from app.jsx. So this is your primary loading page of your application. Everything that you do is loaded from this parent component. React works with the concept of components, and these components are nested. So a component is generally a distinct block of code or a distinct object. You can almost think of it as a page, and within a page, a component may be a certain aspect of that page. And so you can get quite granular with your components. But in essence, every component is a child of a child of a child of a child that eventually goes up to app, which is your parent component. So if I start up this application right now, you would see that all we have at the moment would be a default, just basic React, a React demo app. So let's just wait for it to start up. Okay, it seems to be taking its time. Okay, while it's starting up, we can go back to components. So if we look at our concept of what we're trying to build, we're trying to build a blog site. And so if we remember the APIs that were created last week or last session, we can have a look at where is it? Don't actually know where it is. There was a list of APIs that was exposed to us. And those APIs had a concept of authorization with JWT tokens. Z went quite in depth on this in the previous session. What that means is to access these APIs, to make these API calls, we need to be authenticated. And to authenticate, we need to pass in a username and password. And so the obvious way of doing that would be to create a login page. And so that would be the first component that we'll be looking at today. And so that would be our login form. It's a simple form. It takes in a username and password. It makes a call to the backend to authenticate. Again, refer back to session 2 for this. And if successful, a JWT is returned and stored. So if we look at the code for that page, we can start to dig into our components a bit more. And it might illustrate a few things. My laptop is not playing ball today. Okay, cool. So let's have a look at our components. The first thing we'd notice is we now have a components folder, and within the components folder, we have a new login folder. So let's have a look at the login folder. So if you look at the login.jsx file, this is our React file. This is what creates our form for us, and this is what will allow us to create a web page in inverted commas. So if anybody's familiar with HTML, JSX looks very familiar to HTML. This is using the ES6 style of JavaScript, which means you have import statements in this fashion, where it's import something from something. You also have the concept of using constants rather than variables, and we use arrow functions to define functions. And generally, you return a JSX payload, which is in turn your web page, which gets translated to HTML. And you generally export that as the default export, and that will export your default function. That's ES6. You don't need to know that too in depth, but if you'd see occasionally that JavaScript code in React might look differently. The older the code is that you're looking at, the more different the code would be. Sometimes you see things like objects, that's generally like ES5. So if you look at our login function, you see that it takes in a parameter called setToken. We'll speak about that in a bit. It creates some constants. It creates a function, which is an asynchronous function, and it returns a JSX payload. So let's break this down a little bit. The first thing we're going to look at is this component. This is called a React hook. React hooks are used to handle state in JavaScript. Now, state is a bit of a complicated concept, which we're not going to go too depth into today. But if you think of JavaScript, JavaScript has, if you think of a web page, right? If you load up a static HTML document, it's just a text file at the end of the day, right? You can't really interact with it in any way because it's just a static text file. So using the JavaScript, so that's where JavaScript comes in. JavaScript has the concept of a DOM, a domain object model. Not going to go too in depth on that because it's a bit of a complex topic, and you can read up more on that on your own and Yeah. React, on the other hand, uses a concept of a virtual DOM atop the DOM. Again, quite in depth on the terminologies here. Don't get too scared. It's quite easy to understand. If you think of state as the current status of your application, state allows you to interact with the application. It allows things to occur when you change things. So if you think of state as the values of variables, when you change your state, when you change the value of the variable, occasionally you want something to happen. And in this case, we want our application to do something. So if we look at the login page, for example, we want to say that, hey, when we type in a username, we want to update the value of the username. So that changes the state of the variable username. And so React exports this concept of a hook, which is in this case Usestate. So what the Usestate function does is that it exposes two things to us. The first is a variable and the second is a function. The variable is treated like any other variable. It can be of any type that you define, and it will be used like any other variable. So you can see that we use it here at this point. Set username, on the other hand, is a function that allows us to update the contents, in inverted commas, so update the state of that variable when we want to update that state. So in our case, we say that, hey, when you type in something in the input field, when the value of this input field has changed, so unchanged, set the username. So then update the username, update the value of username, this variable here, to the value that we are typing in. And it's the same concept for password. So that's in essence a React hook, how to manage how React uses it to manage state. This function, this update state function, can be passed on to child components. So how we see it here is that it's used in onChange, right? But we can then see, if we look at the example on submit on the form, it uses a function, a child function, and that uses a, where is it? The set token function, which is passed to us by our parent component, which updates the value of the token variable used elsewhere in our application. So I know there was a bit of a brain dump, so if there are any questions, we can go over it now. Okay, I presume there's no questions.
Yeah.
So,
No question, yeah.
Okay, cool. So if we go back to our app.jsx, if we go back to our app.jsx, we can see that we've added a bit of things to our application now. The first thing that we added is a call to a function called useToken, and that seems to return a React hook of some sorts. So we see a variable and a function. So let's have a look at useToken. So useToken is a default function for this file. What it does is it creates a function called getToken. This getToken function, when called, returns a token string from our session storage. It then parses it into JSON, and then it attempts to get the field access. The next thing it does is it defines a React hook token and set token, and its default value is the value of get token of this function. So whatever this function returns will be the first initial value of this value token. Okay, it then defines a second function called save token, which takes in a parameter user token, and it simply just stores this user token in our session storage as token. And then it runs the set token hook, and it updates the token to this value. Pretty straightforward. Again, we're not going to really speak too much about tokens today. That was covered in the previous session. But in essence, what this does is it stores a session token for our user so that when they log in, they only need to log in once per session. And that is stored in the React memory session for that user in their browser. Cool. So if we go back to our app.jsx, we see that we call this function, we get two values back. One is token, a variable, one is set token, part of the hook, the state hook. And we say that, hey, if there's no token, load our login page, right? Quite simple. So if no token exists, load our login page and then use the hook to run set token, which will update the value of token, which will update our virtual DOM, which will update our DOM, which will reload this page, or at least reload this component. And so when this component is reloaded, if we now have a token which was set by set token, this if statement will now fail and we'd return this portion of the application. I seem to be missing something here. Let me just fix that quickly. Import logo from, what is it? Logo.svg. Cool. Okay. So we can actually have a quick look at our login screen. So if we go to our localhost 3000, we can run through that quickly. So what it does first, right? It runs app.jsx. So when it runs app.jsx, we then run this component, and because we don't have a token currently, if not token passes, and so therefore it returns the login component. And the login component, as referred to earlier, is this basic form with two input fields and a button. Full disclaimer, I don't have any error messages enabled at the moment, so if you attempt to log in with something that doesn't work, it just will stay on this page. So we're going to log in with the default credentials. Again, this was created in session 2. So what will happen now is we've set the state of username to admin. We've set the state of password to admin as well in this case, which is this piece of code here. And then now we're going to run this portion of code, which is on submit, which runs the handle submit function, which is an async function. So another component of JavaScript, or rather, JavaScript, yes, and what React uses quite extensively is the concept of asynchronous functions. Asynchronous functions basically means things that don't occur in real time. So if you think of a call to a backend, a call to our backend could result in a few things. The first is that it could take some amount of time because you're communicating with something that's not you. So you need to wait for that. The second is that this call might return successfully, and this call might also not return successfully. So you need to handle both scenarios on whether it occurs successfully, not successfully, and you also need to tell your application to wait for this response. So that's where, if you're using ES6 at least, you have this concept of async and await. So if you mention, if you have this keyword in front of something, in front of a function, async, it tells JavaScript that, hey, this function is an async function. When you run this function, there will be an asynchronous call contained within this function, and you will at some point need to wait for this function to complete. And so if we look at this, we see an await call as expected. If you see async, you will always see await, and if you see await, you will always see async. So this tells JavaScript, hey, this function login user, wait for it to complete. Once it's complete, store its return value in token and then continue running. So if we look at the contents of the login user function, it simply, as expected, makes a call to our backend. This again was defined in session 2. This is a post method which posts against our backend in an attempt to get an API token. It sends the JSON body, which is our username and password, which is what we entered from the form, because this function takes in 2 parameters. The first is username, the second is password. So if you attempt to log in, this will now make a call to the backend, and hopefully we'll get a token. And look, we do get a token, so that is good and expected. So if we go back to app.jsx, what has occurred? So what happened was we clicked handle submit. So it awaited the call to the backend call returned successfully. That value was stored in token. We then ran the hook set token, running set token. then told the DOM to update the state of the value of token. And since we're referring to token in the app.jsx module component, this was updated, and therefore this code was rerun. But now when this code was rerun, token now has a value because this value was sent from the backend. So therefore this if statement no longer passes, and therefore this is actually what is returned. And so what we see is, well, that is what is returned. Cool. So that's handling a few things that touched on login, that touched on authentication, that touched on tokens, that touched on state. Quite a lot of stuff. And again, I did say there's going to be a lot in this session. I would suggest going through each Git commit, going through the slides in depth, reading the documentation, and try to figure out a bit more what's happening, and feel free to ask questions now or later on in the Discord group. So the next thing we want to do is create a homepage, or let's start with a navbar. Generally, a navbar is one of the first things that we create because, well, it's almost on every page, and it's kind of something that's quite easy to look at and easy to do. So if we look at the git hash, this is a very simple component. So if we just check out this git hash, let's just do that. It's because I made a change to the front end. Live demos. Cool. Okay, so now let's have a look at what we have. So now if we look at the navbar.jsx file, we see a new component. This simply creates a function called navbar. It takes in a parameter called setToken, similar to the login page. It defines a function called handleClick, and this handleClick simply just sets the token via state to an empty string, and then it returns a simple JSX payload. This JSX payload is a basic bog standard navigation bar. And in this case, we have 3 links. The first is a link to your homepage. The second is something to create blog, which we'll handle later. And the last one is just a almost button in inverted commas that when you click it, well, it runs this handleClick function. So we then go back to our app.jsx. We can see things have changed slightly.
I think I have a question, sorry.
Yep, sure.
I was getting an error trying to git commit the hash for the navbar.
Say that again.
I was getting an error. I don't know what, maybe I'm doing something wrong. I don't know. Like I was getting an error for the git commit of the navbar, for the hash for the navbar.
For this hash, have you pulled in the latest branch?
Sorry?
Have you pulled in the latest branch have you pulled in the latest session 3 branch?
Yes, because I've been doing for the login was okay. Okay. And others to this point was okay, only navbar. Maybe I'm doing something wrong.
So let me try checking out that commit again. And so yeah, it does seem to be there. I'm not too sure. Yeah, without actually seeing the error, it's a bit difficult for me to debug that for you. But I mean, if you are on the correct branch, the commit does seem to be present. Yeah.
Your local changes to the following files would be overwritten by checkout. Please commit your change. Oh, did I? Oh, I think I know what went wrong. Yeah. Yeah, I think I know what went wrong. Yeah, thanks. So I think you can continue. I know what went wrong. Hello? Hello?